everybody to this webinar. My name is Mark Kelly, one of the ACC technicians here at Cadgroup. This is a re-recording of creating photorealistic materials in Revit. We had audio issues in the first one. I seem to be afflicted with technical gremlins when it comes to webinars. So we have decided to re-record the entire presentation and make that available as a link so that anybody who missed any of the information during the first one can review it. And also, if you wanted to pass on the link, then you've got a resource that you can send on. All right, so let's get into it. Got a lot to get through here. So why would you bother with photorealistic materials? Well, first of all, I think the fact that you may have attended the original webinar or might be watching this webinar implies that you probably do have an interest in photorealistic materials and see some value in them. But just to go over some of the reasons why they are useful. First of all, they're useful in the sense that they provide a realistic idea for stakeholders. That includes obviously clients as to what you're actually going to get, or close to what you're going to get in a finished design. It's also good for you in a design sense because it starts to give you an idea of how different colors or finishes are actually going to look, again, as close to reality as practical. If you're in a competitive situation, then it's going to make your presentation more compelling. And if you're marketing a current project or future project, then obviously it's going to make the presentation a lot more compelling as well. If you're sending it on to other people, then that gives them a much better, to render, for example, professional renderer. If you wanted to do that, then that also gives them a much better starting point. It could be useful for doing photometric testing. So if you do, if you're doing testing on the amount of heat or illumination on a surface, having an actual real representation of the material rather than a generic representation is obviously going to give you a much closer result. Okay, so there's probably a few different categories into which people might fall who are watching this presentation. Number one, you've never looked at materials at all, or number two, you've looked at them and played around with them, but didn't quite understand what everything meant, or you've got some understanding of them, but finding resources can sometimes seem a little bit hard. And so hopefully we can do a presentation today that covers everybody who's in any of those sort of categories and assist them in becoming more efficient and making nicer materials. So Revit does ship with a library of materials. That's one of the reasons why a Revit installation is huge. There are actually quite a few materials that ship. Now you can take those pre-made materials and use them exactly as they are, or if you have an understanding of how they work, you can manipulate those materials. Some cases you can't. They're just pre-made and you can't make any changes to them. But in most cases, even with the pre-made materials that ship with Revit, you'll find that there are some adjustments that can be made to them. So you can also take those existing materials, make a copy of them, and then edit them to save you time. If you're creating a number of different similar types of materials, then you can do that. You can also create new materials completely from scratch. So in Revit, you can create a new material, and when you first do that, you are presented with a generic material, and that generic material exposes all of the material properties that are available in Revit photorealistic materials, and then you can edit those as required. Now, when I say all of the materials available to Revit photorealistic materials, those actual materials themselves, if you open those up in something else like 3ds Max, then you're probably going to see other controls that are available that are sort of hidden by Revit. But in this context, we're talking about what you can do inside Revit. So those generic materials are sort of your starting point to create a completely bespoke material. Not to say that there's anything wrong with using a pre-made material. If you have something that's really close to what you want, then there's no point in reinventing the proverbial wheel. All right, so let's have a quick look at the way that the material properties are broken down. If you understand how they work, then obviously making a new one from scratch or using a preset one, you'll have a better idea of what all the different properties refer to. So when you do open up the material editor, you're presented with a preview. You can control the quality of the preview, I guess, depending on your graphics card. You might set that to production or draft. If it's set to production, it takes a bit longer for the preview to update to look more accurate. But you can also change the preview. They call it the scene. So you can also change the object, the shape of it in the preview, which could be useful for different things. So if you've got a material that you're putting onto walls, then obviously having a preview of a wall, material applied to a wall, is a lot more useful. So then inside there you have all of these different materials that you have access to, sorry, material properties that you have access to. And those are also referred to as slots. I guess that depends on the actual, like 3ds Max, you might refer to that as a slot. But effectively what we're doing here is we're breaking down all of the material properties into their discrete parts. And what we look at when we're defining a material is effectively the way that light interacts with that material, okay? And the reason that it probably all looks a bit abstract is because what you're doing is you're sort of deconstructing all the different types of interactions into separate components. So whilst you might be, you know, used to looking at the way light reflects off an object in simple terms, like the amount of light that reflects off it, and you know, is it a mirror or is it matte finish? But the photorealistic materials sort of get down into the deep and dirty and have a lot more properties involved in them because they break down the way that light works in a much more discrete series of ways, which gives you control over them. Some of the pre-made materials may have these. Some of these pre-made materials may have some of these slots hidden, and they also may be renamed. Okay, so in a lot of cases when I go through these different properties, I might give alternative names for those properties, and depending on the context of the material that you're using, they may have a totally different name, but they pretty much control the same thing. All right, so when you look at the actual properties, you'll see that there's a variety of different ways to define these different properties, or these different slots, or these different properties of the material. So in the case of some of them, you'll have a choice of 3 different ways of defining it. So you can either use a numerical value, which might be a percentage or just a simple number. And then you have an image, which is a raster image, JPEG, PNG, bitmap. And then you have a procedural map. So it says image there, but it is technically a procedural map. So that's a pre-built, scalable, predefined map that you use for a variety of different purposes. They're quite interesting and quite useful. I do want to spend a little bit of time on those because I think they're actually very powerful. And they can save you a lot of time if you're trying to represent something and you just can't find a resource like an image, or you don't want to have to go into Photoshop and start fiddling around in there. They can be a quick way of representing certain things really quickly. They're quite clever. So what controls you have in a particular slot will vary depending on the material property and even on the actual material itself that you're using, if it's pre-made or generic. So just to explain quickly, a numerical value is essentially where the property of that material and the way it interacts with the light is consistent right the way across the entire material. So to give you an example of something like that, if we assume that a mirror is 100% reflective and it's 100% glossy, that is to say that there's no scattering of the light whatsoever when the light strikes the surface, then we could quite safely assign a numerical value for those 2 properties of that material, because that's something that we want to be consistent across the entire surface of that material. Now, if any of those properties, that reflectivity or the or whatever, like translucency or something, varies across the face of the object, then we might want to look at using a JPEG or a PNG bitmap image to map out, to create a map, so to speak, of the varying different numerical values for that particular object, that particular material. So for example, here in this screen capture, I've got the actual colored image that we see in the rendered view, and that's a JPEG image that's been downloaded from the interface website from one of their floor tiles. And so what it's doing is the renderer is extracting a numerical value for each one of these pixels, and it's based on the actual color in the raster image, and that's tiled across the material at whatever scale and whatever angle we decide. A procedural map sort of works similarly to an image in that it is essentially, creating some sort of numerical value. It might be random noise, or it might be a tile or something like that. We'll have a look at that in a sec. Okay, so the very first cab off the rank when we look at these material properties is what's called the image or the base color. Again, that's depending on the context of the material we're looking at. That will be defined by a color, an image, or a procedural map. Now, again, if we use a numerical value, like here we've got an RGB value, then that means that that's consistent across the entire face of the material. And then we've got, in this case, a JPEG image that's, again, that same example of looking like tiles. Now, remembering that we're breaking down everything into its constituent parts, what you'll see as we go through is that when we talk about the amount of light that reflects off, or the quality of that light, how scattered it is, those are separate controls. Okay, all we're looking at here is just that what they refer to as the base color of the object. Now, there is another control here that you'll see on a lot of these generic materials. It's this ability to fade between a solid color and the actual image that you've loaded up. And so if you put in a green color or whatever, you can actually blend. It's a blend function effectively. So when this is blend, the image fade is set to 100, then the rendering engine will only show the image that you've loaded in. If it's set to 50, then it will be a blend between that color and the image. And if it's set to 0, which you would never do, then it's only going to show the solid color. Okay, so moving on to the next one, we've got bump and relief. Again, those are two different terms for the same thing. So this is defined as an image or a procedural map. It's not a numerical value, and that simulates a depth on a material. I say simulates, but it's not real depth. It's essentially a trick of the rendering engine to fool your eye into thinking that there might be some sort of recesses in the face of the material. So normally that would either be black and white or grayscale. And again, what you're doing is you're using a grayscale image to define values from 0, 0, 0 right the way through to 255, 255, 255, and 0, 0, 0 obviously is black, and 255, 255, 255 is white. And those values then are used to define whether that part of the material is recessed or sticking out. Okay. Now in this example, what I've done here is I've actually used a procedural map. It's a checker map, and it's a checker like squares of black and white. So anywhere where it's the material surface is mapped in that black, it will be recessed, and anywhere where it's white, it will be protruding. And then you've got an amount, and as you crank that upwards in value, that will make the protrusions look more protruded, if that's a word. And so that's how that works. But if you use a grayscale, you might use a grayscale when you are using something like representing something like let's say a stone wall. Now, so you've got your nice little joints between the stones where they butt up to each other, but at the edge of the corner of each piece of stone there might be a radiused corner, and so the grayscale represents a gradual fall off from white down to black, let's say, and so the black bits would be where the stones butt into each other or next to each other, and then you'd have that gradual fall off around the edge, which would give you that nice illusion of the edges of the stone being slightly rounded. All right, so next cab off the rank is reflectivity. Now again, got to sort of think about these things in sort of their discrete little sections. Reflectivity really only refers to the amount of light, the quantity of light that actually gets reflected off a material. Now that, again, probably seems a bit abstract, but it's just the way the rendering engine breaks things up. Reflectivity can be defined as a numerical value, an image, or a procedural map. This can also be named base highlights in some Autodesk pre-made materials. Now, when you use reflectivity, you then use that in collaboration with two other properties, or maybe not. They're maybe not called this, but there's certainly properties there that have to exist with reflectivity. And so you've got glossiness and anistropy. Okay, so I'll come back and explain what those two mean. But just to give you a preview, the reflectivity refers specifically to the amount of light getting reflected off an object. The glossiness, as I sort of mentioned before in the context of mirrors, refers to the amount of scattering of the light, random scattering of the light as it bounces back off the object. So again, this is sort of breaking things down into its discrete components. So you would normally use a grayscale or a black and white image, depending again on whether you wanted to have sharp delineation between the bits that do or don't reflect light, or if you wanted gradual. So it depends on the actual object that you're trying to represent, or again, you can use it just a standard numerical value, which defines the amount of reflectivity constantly. So in this example, probably not necessarily all that fantastic an example, but what we've got is a base color, and then we've got reflectivity here being defined by a procedural map, which is like a tile. And the bits that look sort of silvery colored are the bits that are reflecting light, and then the bits that are black in that procedural map are the bits that don't reflect any light, which again sort of sounds a bit strange and abstract. But then, because our glossiness set to 50% effectively, the light that's reflecting off there is sort of like a semi-satin sort of thing. If it was set to 100, then the light reflecting off there would be a mirror. If it was set to 0, then it would be completely matte. Okay, glossiness, mentioned that a few times, works with reflectivity, numerical value, image, or procedural map. Again, numerical value consistent across the entire material. An image or a procedural map varies across the material. So again, you use whichever one is actually relevant, which actually represents the real material in real life. So that's defining the scattering of reflections. A maximum value is a perfect mirror, 50% semi-gloss, 0 perfectly matte. Of course, nothing like that really exists in the real world, but for practical purposes, if you were showing something as polished chrome, polished stainless or chrome, or a mirror, then you would just use 100%. And you might use 50% for semi-gloss paint, and then perhaps 0 for a matte paint. You don't need to be 100%. You don't need to be super particular about getting those values exactly right. So there also is an additional control here that you find in some materials, especially the generic material, and that's a control that allows you to set the reflections to be metallic or non-metallic. So you're only ever going to set that metallic to metallic when the object is metallic, which makes sense, yeah. But that does subtly affect the way that the photorealistic rendering material works, reflects the light. And if it's set to metallic, it'll start to act more like a metallic object, if that makes sense. It's probably a very, very vague description, but if you ever switch between those two, you'll see that it is quite interesting the way that the material changes, the way it reflects light. The other thing I mentioned that works in collaboration with reflectivity is the property of anistropy. And in this case, down here, you can see that this is controlling anistropy, but it's not called that very helpfully. It's called direct and oblique. So what are we talking about with anistropy? Well, that's a real world property that you may or may not have actually realized occurs on a lot of materials. So for example, if you've got a piece of black leather, which has a sort of perhaps a semi-gloss type of finish on it, if you're standing looking at the piece of material directly in front of you, the amount of reflections on the object might be quite limit, not very much. It's my technical term for the day. Not that great. However, if you move your head on an angle, so you're looking at quite a oblique angle to the surface, you'll find that the reflections actually increase. Okay, and that's a natural phenomenon. You find that, I think, with glass as well. If you're standing directly straight onto a piece of glass, you don't see reflections. As soon as you move off on an angle, you'll start to get a lot of reflections. And that's something that we can represent here using these controls. So it's either called anistropy or direct oblique, and it may also have different names with some of the pre-made materials. So in this case, this is a piece of leather. I've set the oblique reflections to be 99, the direct to be 23. And you can sort of see in the preview there that it's simulating a little bit of what you would expect on a real piece of leather. All right, so transparency defines the amount of light that actually passes through an object. Okay, so again, numerical value, image, or procedural map. Something like air has 100% transparency, and something that's totally opaque has 0% transparency. Now, interestingly, as strange as it might sound, if something's completely invisible, you're actually, yeah, it will, even though it's air, you do have other controls that you need to take account of. So the other two controls are translucency and index of refraction, or IOR for short. Okay, so transparency is purely looking at the actual amount of light that passes through, the amount in lumens that passes through. And then in addition to that, we've got this other property, which is translucency. So a little bit like reflections, the translucency defines the scattering of light as it passes through a transparent object. So something like 100% translucency will give you something like a really frosted glass or a piece of frosted acrylic. And 0% is something that's perfectly clear, which I'd probably use for something like glazing on an office building. I would always set that to 0%. And you probably think, well, that's not true. That's not really how glass works. But yeah, for practical purposes, you just set that to 0 probably in your renders. And it would actually probably make your renders slightly faster as well, because it has to do less calculations. Now, another thing too is you just have to be a little bit careful to not be too heavy-handed here with the translucency. If I set translucency to 100, then that means that effectively anything behind the object or through the object is invisible. I don't really see any image. So if you're trying to represent something like frosted glass, you'll know that, you know, even with frosted glass or frosted film on glass, you can still see some image of something behind the glass. And that's, you know, where you probably wouldn't want to make that 100%. IOR, refraction, that's the quality of how light gets bent naturally as it passes through different types of objects. So an IOR of 1 is a vacuum or air, and it has no refraction whatsoever. 1.5 is glass, so that's warping, I don't know, sort of a unitless number really. It's defines how much the glass warps the light as it passes through. One word of advice though, even though 1.5 is glass, I would never ever really use high values like that in photorealistic materials, especially if you bring something like that in 3ds Max and render it. You get some really, really strange effects, like, you know, the old Coke bottle glass effect. It can look really, really strange and unnatural. So it's very small values of IOR I would recommend. I might be proven wrong on that one, but it certainly is my experience. Okay, so the next one I want to look at is what I've referred to as special material properties. In a way, they're not really special material properties, they're just inbuilt material properties, but I sort of think they're special because they're cool. So one of the ones I want to look at here is cutout, and this is defined as an image or a procedural map. In this case, you want to use a black and white image, right? You don't want to use a grayscale image. You certainly don't want to use a colored image. And that defines the portions of the material that are cut out. But when I say cut out, what I mean is anything in the image file here that's black effectively is invisible to the renderer, right? It will not render. It's like it doesn't exist. And anything that's white gets rendered, okay? So if I define a material with a black face on it, and then have a cutout map like this, then effectively, just like in the preview there, you can see that the bits that are rendered come up that black color, and the bits that are black in the cutout map effectively don't exist. If you ever tried to create an object with thousands of little perforations in it in Revit, like a wall or a component family, you'll know that eventually Revit gives you a warning and says, nah, can't do this, you've got to use materials. And that's where using something like a cutout map, perhaps of perforated steel with little, like an image with circular dots in it. So you'd have white dots, sorry, black dots where the circles are. The circles would be black, and then you have a white background. And that would give you a nice little illusion of a perforated steel with those little circles on it. All right, another one that's interesting is self-illumination. So this is a property that makes materials emit light. So when you define or tick the self-illumination box, you're asked to fill out a number of different property boxes there. First one is color, is filter color. So that creates a sort of a filter on top of everything else. Then we've got luminance, which is lumens, the amount of energy that's being emitted by it in lumens. And then you've got color temperature in Kelvin. So daylight's about 6,500. If you go for, let's say 3,000, then you're going to end up with a very warm light. If you go for anything above 65, then you're going to end up with what you characterize as a blue light. Now, this is actually pretty useful because if you're trying to simulate something like signage or LED strips, trying to get Revit lights, photometric lights, to work correctly can be very problematic, especially if you had, let's say, some sort of bulkhead and you had curved soffit on the bottom of the bulkhead, and you had LED strip lights that ran around the curve. Trying to get lights to work could be pretty diabolical in Revit, photometric lights. So by defining that, a piece of a solid that has self-illumination on it, you can actually get some really nice effects and make it look quite realistic and save yourself a lot of trouble using photometric lights. One thing though, I would caution you, if you're doing photometric calculations, they may not work quite correctly. Sort of calculating the photometric values may be a little bit confused by self-illumination. But that's a really neat little property. All right, another one which is useful is roughness or weathering. Again, that will sort of vary in name depending on the context of the material. In the case of a generic material, it's called weathering. But what it's effectively doing is it's creating random roughness in a material or an image. And it's useful to show wear or imperfections. So when you're looking at a photorealistic render and you sort of struggle to think that it's real or fake, one of the things that makes it look real and sort of gives you that suspension of disbelief is imperfections. So ironically, one of the things that rendering engines have to have built into them is this idea of slight imperfections to make things look real, because if they don't have imperfections, if they're totally uniform, the surface is totally uniform, then your brain goes, no, sorry, I've never seen anything in real life that looks like that. And so you have that suspension of disbelief. So you can define weathering by a numerical value, an image or procedural map. It would usually be a grayscale or a black and white map. You can use an image, but you can also use a procedural map. One of the useful ones is the noise map, which we'll have a look at. And so again, when you're using an image or a procedural map, this great grayscale value defines the numerical value at the point that's mapped across the object. So that's that. Let's have a look at this in Revit. So before we do anything, I want to mention something important when you're dealing with customized materials in Revit. You've got to go to File, and you've got to go to Options, Rendering. And then what you need to do is you need to click on the plus button and then click on this little epsilon. And then you need to define a folder where you're going to place any images that you're going to use for your customized materials. Now that folder could be local on your hard drive, but better still, you'd want to have it on a network drive. And possibly if you're using Autodesk Construction Cloud, you could host that, create a link, I think, to the folder on the Autodesk Construction Cloud as well. So that's something very important, which I need to mention. All right, because you could go to do the render and it might not work because it doesn't know where that material is. All right, so let's click on this very first one, and we're going to just go into the properties. And this is just a shorthand way of getting to the materials. Actually, before we do that, let's duplicate that. Like all good Revit people, we should make duplicates of system families before we make edits. So I'm going to access the material by clicking on that epsilon there, and then I get into the material browser. Again, I don't want to be writing over concrete masonry units. As soon as I do that, every single wall in the project is going to change. So I need to go here and go create new material. And then I get this generic material appearing. I right click, I go rename, call it carbon fiber. Now, so what I'm going to do, first of all, is show you some examples of pre-made materials that we can use, that we can just tweak slightly to get a finished product that we want. So we make sure that's active. You go here to the open close asset browser. You'll see there's quite a few physical materials that have been installed. The ones that we're going to be looking at today, though, are going to be the appearance library. So to save myself time, I can just put in the name and see it comes up. Yep. So I might need to just click through here. Okay, we've got carbon fiber. Just double click on that one. Now, I've double clicked on it, and it probably doesn't really look like it's done anything. But if I close this up, you notice that this is now populated. So here I've got the scene, and this is where I can change this to different previews, so to speak, of different types of objects. The torus is very useful for small things, for small scale materials. If I did that on a sphere, it's just not going to look right because it's sort of representing something that might be, let's say, a meter in diameter. And of course, that level of detail is just going to get lost. So there's that. There's also production and draft. So obviously, if it's set to draft, it's going to be a lot faster. The actual quality of the render is just not going to be quite as good. So just looking at this pre-made material, we've got a lot of controls there that are similar to that sort of generic material, but some of them are sort of missing, or some of them have been given different names. So we've got the base color, which obviously is going to be maybe not quite a black, but certainly a charcoal color. Then we've got this thing called base highlights. I did mention this in my PowerPoint, but effectively, this is in this material controlling the reflectivity, the degree of reflectivity through a map. Okay, now when you see that map there, if I want to edit it, I can left click here and go edit image, or I can just click directly into that window. And then I've got controls here to control the map. So a few things I've got actually is the ability to control the lightness and the darkness. So I can actually change that if I need to, rather than going into Photoshop. I can invert the colors like so, and we'll come back and have a look at this property. It's quite an interesting one. You also note that in the preview, effectively, the image itself is an image that's got this sort of weave in it, and it's 4x4. And what it's doing is it's showing me that what it's going to look like when it's tiled. So these ones around the outside edge are sort of tiled versions of that same image. So it's showing me how that all interacts together. Then I've got a scale that tells me that that particular twill weave there is going to be, those 4 bits are going to total 8.4 millimeters. So let's just change that up a little bit. Let's make it, say, 15. I'm just going to show you something here. So that's going to change this preview to make that look a bit bigger. Okay. But also when you do make changes to those images, just be conscious of the fact that there may be other images that are also being used, and you need to change the mapping on those as well, because if you don't, then they're going to be out of sync. So what we've got here is, it's called relief pattern or bump, same thing. So it's a bump map. And if I click on there, I just need to make sure that I set that to the same scale. And also I've got anistropy being defined by the orientation being defined by a PNG map. And again, I need to make sure that I sync those up. There's a few other controls here as well. I even have the ability to create cutouts and stuff as well if I wanted to. Let's hit the apply button. Don't really need to hit the apply button, it'll be applied anyway, but just click OK to get out of there. Now we'll come back and have a look at this again. Did that apply that? It's not convinced it did. Yeah, did. Okay. This doesn't look quite how I expected, but anyway. Okay. We're going to have a look at this in a bit more detail, you know, just to see what it actually looks like in finished product. All right, so that's the first one I wanted to show you. Now the other thing that one of the other pre-made materials, which I find quite nice, I'll click here. I'm going to duplicate this and call it green metallic. It's not obviously something that you'd call a wall, but anyway. Again, we'll go to the material properties, and again, we will make a new material. Right click, rename that one, call it green metallic. And then we'll click on our little browser here. So we're going to the preset materials. You see that under appearance, got metallic paint. There's a few different ones in here. So I'm going to click on flaked satin. Did that update? Nope. I single clicked. Not double clicked. That was my mistake. All right, good. So what we've got then is a base color. And this sort of works pretty much like you would expect real car paint to work. We've got a base color. And then on top of that, you've then got flecks of a different color. So it could be whatever color you want it to be, let's say yellow. And then you've got size. Now, you don't want to go overboard with the size because that will start to look a bit weird. If we say torus, that'll start, well, anyway, it doesn't look all that fantastic, but we've also got the ability to add pearlescence, which could be chromatic or a different color. So if you wanted to represent some sort of fancy paint color that has a pearlescent finish that changes color depending on the angle, then you can do that as well. And you'll also see that there's some special features here for top coat. If I change that to car paint, get this really beautiful glossy finish. And if I change it to, so, you know, something like smooth is like, in reality, you're never going to get 100% smooth car paint finish. The top coat is always going to have minor imperfections in it, unless it's a Rolls Royce, perhaps. But most car paints will have some tiny degree of imperfections, which is referred to as orange peel. It's caused by, I think, surface tension. As the lacquer starts to dry, it sort of dries differently in certain parts, and it has a sort of a dimpled sort of look to it when you look at it really closely. Probably best to not to look at your car paint really closely. Could be a bit discouraging. All right, so then we've got this thing called a tint. Now, this is actually something that occurs in a lot of materials. And so the way I think of tint is it's like a color on top of everything else, but then acts like a filter to only let light through and filter out light from whatever color that's not. Does that make sense? No, maybe not. So you'll find that on things like, well, in this case, obviously metallic paint. You might find it on the preset timber finishes. So it might be referred to as lacquer. And effectively it is like a lacquer in the sense that it's a, you know, a very, very thin covering over everything that then filters out light as it passes through. All right, so that's the metallic paint. click to get out of that. But not very happy with me. Oh yeah, there is my problem. I didn't have it set to realistic. Whoops. Okay, so there you go. You zoom in there. There you go. You can see the finish. All right, cool. All right. So next thing I want to look at is just a little trick. I did mention it briefly about that the mapping. So let's just go in here. And again, now just be aware, if you do have a material in your project that's pretty close to what you want, you don't need to go through that whole process of going into that asset browser. So let's just say that you had wood planks, for example, and you needed a different color of timber, but you like that general image. So you could right click and go duplicate. If it's a pre-built material, you can just use this duplicate material assets. If it's a customized material, you just need to make sure that you use duplicate using shared assets. You won't get that in previous to Revit 2024, by the way, just to be aware of that. So I'll just go in here and let's see if we can get this to look a little bit different. So we can click here and we can, yeah, the brightness is fine. We could go in here and change the tint. Doesn't really give us much control over there. We can also add a stain. You can see there that if I add a stain, which is slightly yellow and bright, then that will actually give me that illusion of like a blonde timber. Okay, bit of a shorthand way of doing it, but if it looks right, then there's absolutely no reason why you can't take that other material, copy it, and just make some little tweaks to it to get it to look like what you want. Okay, so if you had like a really rough timber, you can crank up the value. So you can see the relief pattern here, the bump map is actually quite cleverly based on the actual image. It's just a nice little thing in that particular material. But I digress. I'm going to create a new material here. Asset browser, whoops, asset browser, and I think it's carpet striped. Didn't like that. Oh, yes, it did. Okay, so that is carpet stripes. Let's pick one here. Medium light. There you go. Okay. So there's our bump pattern. Now, I would typically not really use bump maps on carpet tiles, right? That to me is a bit of overkill. Generally, you don't want your carpet to be have like relief on them because it's just going to look a bit weird. Plus, if you're rendering it, it actually increases the rendering time. So by turning off properties in your materials, they still look right, then you can actually save yourself a bit when it comes to rendering, interestingly. But there is this roughness. Now, I did mention this is in the context of roughness or weathering. So what I can do is actually take that image and then apply a degree of randomness to it to make it look either sort of feathery or really crisp. Okay, so really it depends on what you're trying to do. So that's that, but what I want to do is have a look at this property here. So let's just go into the map, and we can see there that we've got 3 tiles, and they're going to be 600 by 600 tiles, right? So we need to set this to 18 by 18. So let's change the scale. All right, so let's go to graphics. So in our hidden line views, our working drawings, we want that floor to be represented with a model fill pattern that's 600 by 600. So that's that. So we've got that defined. And you'll see here that I've got this control here. Actually, I'll come back here, go into the map. Now, just watch what happens when I click Link Texture Transforms. It doesn't look like anything's happened. But what's going to happen is Revit's going to overlay the texture on top of that model pattern that I've used, right? So let's just see what that actually really what happens in actual real terms. Nothing has happened. Why did that do it? Well, okay. Did I do wrong there? Did I do something silly? Be the first time? Well, that's strange. Okay. Very strange. All right. I'm sure if you're watching this, you probably picked up what I did wrong there. The joys of doing multiple things at once, like talking and trying to do stuff on the screen. What do we call this? Gray carpet, maybe? I'll do anyway, just for the sake of this. Link. Done. Get rid of that. Graphics. That one. 600 by 600. All those. 600 by 600. Get it right in the night. Okay, so what does that actually mean? Let's finish that off. Okay, so there's the carpet there. If I switch to realistic mode, or not realistic mode, switch to hidden wire mode, and then just tab through to select that, and then rotate that 45 degrees, and then go back to realistic mode. Just deselect it, you'll see that that's actually transformed. And if we go back to the material properties and the graphics and texture alignment, you'll see sort of a preview. You can change the alignment as well. All right, good. So that's just, I just wanted to show you that. Sort of mucked it up a little bit, but that's cool. All right, so let's keep going here. And we're going to look at some interesting things that you can do. If I click on this floor here and go to structure, I'm going to make a new material. Again, rename. Got to say it in capitals because we're sharding. All right, so keep off the grass. Make sure that's the actual active material. I might have clicked off it before. So I'm actually going to use a pre-made one because it's just a nice little starting point to help me do what I need. So it's just this one here called grass, dark rye. And I'm going to use that image map because that works pretty well for me. But then I'm going to go to bump, which it already has, which is an image, but I'm going to swap that out for a procedural map. So this is the first sort of look at procedural maps. In this case, I'm going to choose noise. And you can see that in this case, the two colors that the noise is made up of is black and white. And that's good. I want there to be a maximum difference between the light parts and the dark parts. The sizing of it, I'm going to change that and make it a lot smaller. And everything else I'm just going to leave as is. The preview did change, but it may not necessarily seem that obvious as to what's going to happen. But to sort of have a bit of a breather and get an idea of what all of this looks like so far, let's just stop making materials for a second and then let's just examine where we're up to. So somewhere in the background, landscape's lurking around. Yeah, there it goes. All right. So what we've got then so far is we've got the carpet and we've got the carbon fiber, which looks quite nice. Just sort of zoom in on it, change the light, sort of get more of an idea. And then we've got our very nice metallic paint. Now, because these are flat surfaces, they just don't look terribly interesting. So obviously, as you put these onto curved surfaces, I mean, one of the reasons why metallic paint looks so nice on cars is because they've got curved surfaces and they pick up the light from different angles. So that's you know what makes something like a metallic paint looks much nicer. All right, so let's click on this end wall. And I want to show you one of these sort of special, I call them special, properties of materials, and it's the cutout. So again, let's make sure I get this right. Create new material, and I'm going to say rename, call it wire, oops, chain wire, put the old caps lock stuck on. All right, I'm actually just going to use the generic material this time. And I'm going to set the color. Let's just say it's something like a surf mist. It's sort of grayish color. That's the base color. And then I'm going to look at the glossiness and I'm going to say, well, it's fairly matte. Most of the colorblind colors are sort of a dull, sort of semi-matte finish. That's cool. Next thing I want to do is go to cutouts. You see, as soon as I click on that, then it tries to make me use it opens up this dialog to get me to use an image map. And you can see I've got one here called Chain Link Cutout. So I'll click on that one. Again, cutout maps want to be black and white. So I'll go here to the preview, and that will be a wall. Now, one of the things about this chain mail, when I do have a single layer of material on a wall, what Revit's going to do is it's going to wrap that material around the edges. So we'll come back and change the thickness of the wall. Now, the other thing I want to do just to sort of create that nice illusion is I actually want to use a bump map. Excuse me. Now, the bump map is actually grayscale, okay? And it has that sort of illusion of the wires wrapping over each other. Excuse me. So just need, obviously you need to look at the scale of it just to make sure the scaling is correct. If I change the scale on that one, I need to change the scale on this one correspondingly. I can control the amount of bump. So let's click OK. Let's click OK. And you get to put that chain happening. So what you would want to do though is set that to, well, obviously I should have created a copy of the wall family before vandalizing it like I just did, but you can see that you actually see through the object. And of course, that's going to look a lot better when it's rendered. All right, so an example of using a procedural map. I want to show you that because procedural maps are actually quite useful. Now, just a word of, I suppose, advice, warning, whatever you want to say, about these procedural maps is some real-time rendering engines can't render procedural maps, okay? Just something to keep in mind. But let's just do something here on this wall. And let's create a new material. And we'll rename that one and we'll call it something like colored concrete panels. All right, so we're going to start off with a generic material, and we're going to use two actual procedural maps here. So for the face of the material, and I'll switch to a wall again, because that's the context of what we're looking at. For the face of it, I'm going to click here, and I'm going to use my old friend noise. But there's obviously a number of different ones here that we can look at. We can get simulated timber grains and so forth. It's useful to keep an eye on the preview in terms of sizing to make sure that we're sort of getting the sizing right to look like what we want on the preview. But what I'm going to do is I'm going to change the colors. So instead of it being black and white, this is going to represent different variations of colors that you would expect to get on the face of concrete. So let's just go here. Actually, further down we get, the more grayscale, the less saturated it becomes. So I'll just do that. And then for this color, I'm going to make that sort of a variation of the same, but slightly lighter. So I'll just go there, just get out of the greens. Okay, so it's pretty subtle, but you can see that that's creating a nice sort of semi-random effect for the face. So I didn't have to get an image. I could have just used the noise. All right, good. So glossiness, let's set that to 50. Reflectivity, let's give it a slight reflectivity. Again, we'll just set that to be slightly less directly and then a little bit more obliquely. Yeah, that's all good. And then the next one that we're going to do is we're going to use a procedural map to define the bump. So you see that when I clicked on that, it actually opened up that dialog. So I'll cancel that and go over here. And we're going to set that to the tiles. So this is an interesting one. So again, we've got the preview. It's saying that this is a tile here that's 4, and it's going to be tiled over 300 mils. I'm actually going to unlink this. I'm actually going to set the width to 24 and the height to 12. All right. So it's not really looking like much is happening in the background. But one of the other things I want to do, though, is have a look at the tile appearance, because this is quite neat. If I change the tile appearance to, let's say, white, and then change the color variance, just watch what happens here. Just give it a very tiny amount. Okay, so what's actually happening is it's putting in this semi-random variation in the actual tile. So the tile bit is this bit here, and the gripe is the bits in between, right? So what it's going to do is it's going to make the faces look like there's a tiny amount of variation between the depth of the different faces. Now that might be an effect that's useful to make things look real. You might not want that. You might want that to be set to 0 because you want everything to look uniform. Just to be aware of the fact that you do have those controls. So we'll set the gripe color to black. And then if we go here to gap width, we can actually increase the gap width. Let's make it 1 by 1. So that makes it a lot wider. But there's an interesting thing here. We can go to roughness, and we can actually add in a degree of randomized sort of roughness or irregularities in the graft. Don't want to overcook that. As again, that's one of those settings where you can very, very easily overcook it. So if we go back to here, and then we'll crank up the amount, see if we can actually see it in the preview. It's not really super obvious, is it? It'll probably be more obvious when we actually get into the project. So let's just OK that. Let's make sure you hit the OK button. And then let's have a look at that. So there we go. There's our tiles. And you can see that sort of, it's a bit blocky, but you can see that sort of randomness in the gripe. All right. So what happens if you've got a material that you're trying to represent that's a real life material? Well, I'll click here on that little bit of floor. I'm going to go structure, edit on that, new material, right click, rename. We'll call this interface big apple 600 by 600 tile. We'll go here to image, and we've got interface big apple. All right, I'm only going to very slightly add a tiny amount of reflectivity and make the glossiness 0. Now, technically that maybe not actually 100% right, but we'll just go with that one. Now we're just going to make sure we get the sizing right, okay? Now that sample, when I downloaded it, was a sample of 4 by 2 tiles, okay? So that means that the width, I have to unchain this, unlink it. The width was 24 in a real physical scale, and the height is 1200 in a real physical scale. So all I should need to do is that, and that, and that, and we've got our carpet tiles there. That's a really high resolution image, by the way. If you get a really, really big image, which a manufacturer will probably give you, like interface, you'll find that their images that you can download are usually pretty big. So you might want to go into Photoshop and do a little bit of tweaking there to reduce the image size, because it might actually make the render a lot slower. All right, so self-illumination, that's the last one I want to look at here. We've got edit in place. Click on there, go to material, new material. Again, I'm just going to use one of the generic materials as a starting point. Rename that one. I'll call that say LED cyanide. And we'll make the base color white. Otherwise, we're going to get some really weird things happening. Let's not add transparency. Now, sometimes, there is, in this case, like an LED piece of signage will technically have some tiny amount of transparency, and will have translucency, for example, right? But in real terms, you don't really need to worry about doing that, okay? Especially after you apply self-illumination. So yes, those things are technically true for a piece of, say, acrylic sheet over a light or an LED strip or something like that. But in real terms, it's all about getting it to look right. And if it looks right and behaves correctly, then there's no need to sort of go to those lengths to try and make it absolutely 100% real. So I've added in a color filter. Well, actually, the color filters just stayed the same. If I add in a color filter, you can see it's a bit like adding a piece of colored acrylic on top of a light source. But in this case, it's white acrylic. It's, let's say, going to have a lampshade sort of lightness, or maybe let's make it a bit bigger. 2500 lumens. Color temperature, I've made it slightly warm white. So in the view here, it's not really going to look like much. If we go to a real-time rendering engine, we should get something that looks a little bit nicer. Let's wait for it to do its thing. All right, so we've got, just as a recap, we've got that carpet that we added. If I just zoom in on the grass, actually. There is a sort of a depth there that's being simulated, so that might be a useful way of representing grass on a render. We've got our glowing object here. If I just change the time of day, then you'll start to get much nicer understanding of what it's doing. So you can get these really nice effects here by using self-illumination. But you've also got, don't forget, inside Revit, you've got a few ways of actually doing photorealistic renderings, okay? If I just go here and create a camera view, like so. Set that. Oh, that was a smart move. Hang on. Try that again. Yeah. Okay. So, we can just set up a view like this, and then we can go into view, and you see we've got the ability to do cloud rendering and also internal rendering. And then you can start to look at the light. So interestingly, if you've got self-illumination on an object, it is actually considered an artificial light. So if we say that we want this to be lighting exterior, sun and artificial, then that will actually show it will calculate the illumination coming off the object It's got self-illumination, and then we can just set the quality settings to whatever we want to, and then just do a render. So there you go. That's a little bit or a lot about photorealistic materials in Revit. So all of these materials will look correct in real-time rendering engines, and also your internal renders. If you shoot those out to 3ds Max, then the guys that are in 3ds Max will invariably probably want to tweak things to make them look exactly the way they like them. They might even swap them out for their own materials, but they can at least use some of the images and stuff as starting points if you've supplied them with them. So thanks very much. I hope everybody's gotten something out of that. Perhaps if it's just inspiration or just a little bit of information about some of the different settings that you've got inside materials. Thank you for watching this video, and I'll catch you next time.